Thanks for choosing products from Synovision. Today I will introduce the Cardiac Calcium Scoring plugin, shortened as CCS. It is used to quantitatively evaluate the overall coronary calcification plaque load and assess the risk of cardiovascular events. The commonly used scoring algorithms are the Agatston score, volume score, and mass score. Agatston score is commonly used in clinical scenarios. The calculation is based on the weighted density score given to the highest attenuation value, HU, multiplied by the area in square millimeters of the calcification speck. The density is measured in Hounsfield units. And score of 1 for 130, 199 HU, 2 for 200, 299 HU, 3 for 300, 399 HU, and 4 for 400 HU and greater. For example, if a calcified speck has a maximum attenuation value of 400 HU and occupies 8 SQM area, then its calcium score will be 32. The score of every calcified speck is summed up to give the total calcium score. Let us show the operation process of CCS. In the patient management list, select the study, and then select the sequence for cardiac calcium score in the list below. Click the right mouse button and select the cardiac calcium scoring plugin in the Add Process menu to enter the analysis interface. On the cardiac calcium score analysis interface, the labeling of calcified coronary is the most critical step in CCS. For vessels LMA, LAD, LCX, and RCA, they are already displayed on the vessel list by default, and will be distinguished by different colors in the 2D mode image. We will show how to extract the calcification of coronary. There are 3 methods to mark calcification in coronary. First, manually extract tissue. Select the vessel intend to extract. Click the manual extract icon. Hold down the left mouse button on the calcium speck, and simultaneously hold down the keyboard Shift key to sequentially mark the calcified speck at different levels on axial image. Click the Fill Hole option to fill the internal holes of the tissue. Scroll to find more calcifications and repeat the same steps by press the Shift key and simultaneously hold down the left mouse key until all the calcification is marked in this blood vessel. Second, dyeing. Define the radius of dyeing circle first. Click on the dye icon to dye calcified speck on current slice. For example, to extract the calcified speck on the left anterior descending artery, select LAD in the vessel list. Browse the image in axial viewport to search calcification on LAD. Press the Dyeing Tool button. Place the mouse over the axial viewport. Then hold the left mouse button to dye the calcification on LAD. Release button to complete. The calcification will be extracted automatically and labeled in orange. Click on the slide bar to activate it and use the mouse to scroll down, and then complete the extraction on the next slice. After done in all slice, the total score of LAD is updated in the form. Third, add to each slice to extract the calcium speck on current slice. For example, to extract the calcified speck on the left main artery, select LMA in the vessel list. Browse the image in axial plane viewport to search calcification on LMA. Click the Add to each slice icon, place the mouse over the axial viewport, then hold the left mouse button to draw ROI including the calcification. The calcification part will be extracted automatically and labeled in red. The score automatically displays on form below. Click on the slide bar to activate it and use the mouse to scroll up or down. and then complete labeling on the next slice. After done in all slice, the total score of LMA update in the form. Calculate calcium scoring. Click to complete the calculation the overall score. The results are displayed in the CCS result form. Score displayed. Display the calcium situation of a certain vessel in the current slice. Edit report. Click this button. The interface jumps to the report editing interface and automatically reads the CCS analysis results. Now I will introduce the CCS layout. The left side is the viewport area, shows the axial plane image, the axial MIP image, and coronal plane image by default. The blue line displayed in the MIP image represents the coronal plane. Drag the blue line to browse the coronal plane. The green line displayed in the coronal plane represents the axial plane. Drag the green line to browse the axial plane. In the axial plane 2D image, scroll the middle mouse or drag the slider on right side to browse the images. By default, all pixels with high attenuation more than 130 HU will be marked in yellow. Highlight mark icon on the tool panel is used to turn yellow display on or off. Double-click each viewport in the view area to quickly switch between the single image layout and default layout. At the bottom is the CCS analysis result form. The right side is the tool panel. Patient and series selection display on the top. Specific tools for CCS locate in the middle area. First is the option for slice selection, whole series or partial series. To define analysis based on the entire series images or partial series images. If you want to perform partial series analysis, select the partial option. On the coronal image, the red marker line for area adjustment will appear. By dragging it, we can select the analysis scope. After the scope is defined, click the check mark behind the partial option to complete the setting process. And the pixels with high attenuation in yellow are marked within the selected range. If you want to modify the analysis scope, click the reset next to the check mark. This is the vessel list. We can select the vessel and double-click to modify the vessel name. If you need to add a new vessel name, click the Add Vessel. A dialog box for adding a vessel will pop up. Input the name of the vessel and select the color for vessel staining. It should be noted that the named vessel cannot be renamed, and a maximum of 24 vessels can be contained in the vessel list. Click Delete Vessel to delete the selected vessel. But the default 4 vessels are not allowed to delete. This is the opacity icon. Click it and drag the slider on the pop-up window to adjust the transmissivity of the highlight marks in the blood vessel, which is convenient for better observation of the original image. Below the vessel list is the tissue extraction editing tool. We have introduced it before. Expand. Click to spread the selected calcification area to the surroundings, so that the calcification area is displayed more fully. Erode to shrink the extracted tissue so that the excess tissue is reduced. Other tools includes Undo. Click to undo the previous operation. Reset. Click to restore to the default state. Setting. Click the Setting button in the pop-up box. You can set the calcification threshold and parameters of score calculation. Calculate calcium scoring. Click to complete the calculation the overall score. The results are displayed in the CCS result form. Score displayed. Display the calcium situation of a certain vessel in the current slice. Region measurement. Measure the calcification of the extracted blood vessels in a certain region. Click to select and outline the region on the axial image. After the region measurement, the corresponding parameters will be displayed, such as score, volume, the maximum CT value, the minimum CT value and average CT value in a dialog box. Select the marked measurement region and use the delete key on the keyboard to delete the active measurement region. Edit report. Click this button, the interface jumps to the report editing interface. Overlay to decide the four-corner information is displayed in the view area or not. Linkage control whether the window width and level of the three windows in the view area and the zoom operation are linked. Highlight mark turn yellow display on or off.